Hello, this is Robert Guderian, and today we are talking about the basics. We don't expect that you've used a programming language before this class. So if you haven't, don't be afraid. We're starting from square one. Everything's built on this foundation, and it says, make sure you know how these fundamentals work. Today we're just talking about literally a play button. We're going to put a little bit of code in, and we're going to run it, and we're going to see what happens and why. And we're going to talk about different parts of the environment that we are encouraging you to use for this class. And if you've used a programming language before, I'm going to put a few drops in here for you. And if you haven't, don't be afraid of these. These are just to link back to people who have done some of this in high school or in a previous life somehow. But from the top, what's a program? A list of instructions that completes a task. That's it. Programming languages are very predictable, and we say, do these things in this order, and that's all they do. They don't do anything smart. They might look like it sometimes, but really it's just executing a list of instructions. That's it. Code is the language that we write. So that, in this class, we're writing Python code. Python is a programming language. There's a few others. We're going to talk about a few of them in today's class just because it's fun. And they map to computer instructions that makes a program that will run. An executable is just a fancy word for something we can run. If you've used a different programming language, potentially in high school or again in a different life, you may have made an exe, which is an executable program. Or if you're using a Mac, it might be a .app. If you're using a pure Unix environment, that probably doesn't have an extension at all. And it's just a file that the computer knows how to run. And that is a list of instructions that it runs. And it's written in code. So they all link together. A function, we're talking about this in terms of code, and it is a task that will do a job. We're going to see one today called print, and print will print things to the screen. It does one thing, and it does it well. That is what functions will do for us in this course. And a library module, we'll use a few of these in this class. We'll use one called NumPy that will do matrix stuff for us. We're going to use one called math that does mathematical functions for us. We'll use one called random that gives us random numbers, which is actually probably more interesting than you'd think. And all of the things in these modules have something in common. So everything in random will be about random numbers and different ways to create random numbers. Everything in math will be about doing math things. Let's talk about sine. Let's talk about powers. Let's talk about logarithms. Those are all there. And we can use them. We don't have to write them from scratch. These things we will import. That's actually a Python keyword. And we will just use them for free. And Python has lots of these built in. And in the end, we're going to build something called an algorithm. You have seen these before, and it's a recipe to do something. So if you're making cookies, you're going to grab some ingredients, put them in certain amounts, mix them together, put them blobs onto a pan, and bake them at 340 for 20 minutes. If you don't do those things in order, funny things happen. If you try to bake first and just have ingredients that are not mixed together, it's not going to work. And that's because the algorithm has steps that need to be done in order. In that case, you are the processor. You are executing these steps. In this class, we have the computer to do the work for us, but we have to tell it what steps to do in what order to accomplish this task. And that's how we start to automate things. And my goal for this class is that you could automate parts of your job. If you have a boring job that is repetitive, think back to this and think, can I write a program that can do this for me so I can do something more interesting? Because that is what I truly dream for all of you. So the first program that you write in any programming language is called Hello World. And if I didn't do this, I'd be robbing you of a rite of passage. I'm going to show you it in a few different programming languages because we'll find out why we use Python in this class. So this is C. What do we have here? We have pound include less than stdio.h greater than main brackets, a squirrely bracket, printf, which is not a human word, hello world, /n. That /n is a good one. This is confusing. And C is not a forgiving programming language. C#. Winnipeg's the C# town. You will probably see C# if you do any amount of programming in Winnipeg, class hello world, static void, capital M main, brackets, squiggly bracket, system.console.writeline, hello world. Ick. It's long. It's verbose. I don't like it. Java, which you'll see if you do Comp 1020. If you finish this course and get a C or better, you can take Comp 1020, and I encourage you to. It's a great class. Class, hello world, public static void main, string args, public, system.out.println, hello world. It's a good language, but you have to use 10 words for every Python 1 word. Print, hello world. Yeah, so we're going to go ahead and use this one because it's beautiful. You could read it even if you didn't know that it was a programming language, and there's very few things that are confusing about it. Print is special to us. It is one of these functions we talked about, and it is on a list of built-in functions. We're going to look at a bunch of these as we go through the course. We'll look at things like pow and int and input, and a few of these other ones. Map, if you let me go crazy at the end of the course. Length, we're going to use a few times. So we can use these for free. They're just built in for us to use, and print is one of them. So it's easy, which is nice. Python is platform independent, meaning that I have a Mac. You can see these little buttons here. That will give that away. You might have a Windows machine, and guess what? It doesn't matter. You might have a Chromebook. It doesn't matter. Python will run approximately the same way on all of those devices. We won't get into the points where Python does get a little bit finicky on different platforms because we're writing programs from scratch and not using any of the really built-in internals. Python, guess what, is a computer. Computers compute things, and we can compute things with Python. It sounds really obvious, but you can actually use Python to do any of your physics, engineering, chemistry, mathematical crunching assignments, stats, because it is just a computer, and it's actually pretty good at it. And we can use it in the interactive console to just actually talk to Python. So now we've actually seen hello world, there's this. Let's see what we're using in this class. Let's jump over here. If you're using a Mac, you can see that I have my beautiful default background and a few memes on my desktop. And when I on a Mac, I just type in Anaconda Navigator into Spotlight. Yeah, I think it's great. It's also under your username, opt, Anaconda 3, Anaconda Navigator.app. And it takes a little while to start up. If you have a Windows machine, pause now. It takes like a minute, especially if you don't have a super powerful machine. Not that you need a powerful machine for this class. I've taught this class with the worst computer on campus, and it was fine. So I suggest that you use Spider. Potentially, you might want to use VS Code if you've done some programming before. My expectation is that you're using Spider, but it is not a requirement in this course. And then this takes a little while too, and it's got another splash screen. If you have a Mac, I'd advise not leaving Anaconda Navigator open. It tends to crash for me, and then I have to restart my computer, which it's the only program I've ever known to do that. So I'm going to quit this. Bye. And you'll be dropped into something like this, and I will make this bigger. Nice. And I'll make this bigger. Okay, so print hello world, and you can see it's actually trying to help me right now. This is all of the things you can do with this function. We don't really care about all of those other things right now. We just want to do the first thing and not think too much about what functions do. These brackets are important. They need to match. You can have single quotes or double quotes around. If you're being a real Pythonista, you'd use single quotes. And then there's a big green play button. I'll have to save first. Let's save this somewhere. I'm going to save it to my home folder. No, that's gross. I'm going to save that in my Scratch folder because I'm going to delete it. It's like my Scratch folder is my temporary folder that is super temporary. And then I can just hit play. And you can see over here, this is where my output is. So it feels weird that it's disconnected, that you have this window for code and this is where it comes out. You get used to that over time. And there's some finicky stuff that can happen, and we'll talk about that later once we have more advanced programs. But that's it. I can change what's in here. I like pythons. And there you go. I like pythons. I actually don't know if I like pythons. I don't know if I've ever met one. I can also use this interactive console to do some work. So I'm going to make this a little bit bigger. And I can just type in 1 plus 1. And it's going to tell me that that's 2. Aren't you impressed? Yeah, pat myself on the back. I just added 1 and 1. It looks a little funny because it says in and out. So inputs are, in is your inputs, out is the output of that line. We can actually write Python programs here. Hey, don't. You want to write them here because you can actually save it. When you save your files, save them as .py. And these are just text files. You could hypothetically do this class in Notepad. I do not encourage that, but you could. And we can write more than one line of code. So paste, paste, paste. I like pythons 2. And goodbye, cruel world. When I run this, it will run it from the top line of code down to the bottom. So if I play, it's going to execute the first line of code, then line 3, and line 5, and I just put spaces so you can see it. And out here, you'll see, hello, world, I like pythons. Hello, world, I like pythons too. Goodbye, cruel world. Oh, it's farewell, cruel world. I got the joke wrong. Oh, man, spoilers from the 50s. The witch dies in the end of The Wizard of Oz. So that's it. At this point, all we want you to be able to do is to install Anaconda Python. You'll see some links on the course website. And be able to hit the play button. You can type in exactly what I typed in. There'll be some source code examples on the course website too. And that's it. That's all we need right now. So if you're doing that, you're keeping up. And if you can do math in the console, you're actually ahead of the curve. That console is good for some things. I don't see students do this a lot, but it's really good for iterating on one line of code. If there's one line of code that you're hitting play and then it's going through the whole program and it's like on line 50, and you can actually just put that into the console and just try to get that line right. So you don't have to run the rest of your code, and you just say, okay, well, what am I doing here? Well, why is this line of code not working? Why is there a bug here? And you can just press, I'll switch back over to here. You can just press up and you can get your last line back. Hey, 1 plus 1, 1 plus 1, 1 plus 2. And then if you're trying to work out your equation, or there's some orders of operation problem or some kind of print formatting that you're struggling with, try it out in there. It's actually a really useful tool. 95% of students don't take me up on that, but you can be in the 5%. Okay, so data types. This is a big segue, and it's important for just understanding how computers work and how Python works, and it works a little bit differently than a lot of programming languages. Do you remember what an integer is? You're thinking back, look, I learned that in grade 7 and it's stupid. Yeah, it turns out it's actually pretty useful. And that is a whole number, positive or negative. And in Python, it actually is unlimited precision or size. So these are whole numbers only. So unlimited precision sounds funny. But, and this is not true for any other programming language I've seen. But you can have an indefinite length number. And so you can have a billion digit number and Python will be like, yeah, that's cool. Other programming languages, you can't do that. That's not a thing. So this is actually special for us and it's nice. So there you go, integer numbers. And you've already seen them in code here. 1. Cool. I might be able to even say type 1, which will tell me what type it is, and it says it's an int. Int is short for integer. And type is a second built-in function. This is kind of, you don't have to know it. It's just a useful tool. It'll tell us what type things are. And that'll make some sense later once we talk a little bit more about types. There is another data type called a float, and that is a decimal number. Okay, neat. That is short for floating point. And it's kind of a funny term. So I'm going to, in my interactive console here, say 1.1. And guess what? We get a decimal number. Huh, aren't we excited? If I say type of 1.1, it's going to say it's a float. So the idea of floating point here, this is a comment, is that it's like scientific notation where this number can move back and forth times 10 to the 6. So this number times 10 to the 6 would shift it forward 6 digits, and then that point will float around based on what power of 10 you're moving it around to. Okay, that's it. This does not have infinite precision. This will only ever give us some, I believe it's 12 digits of precision. And if you're worried about those getting past 12 digits of precision, we'll have to use integers and reuse them in a different way. And we'll actually just do the scientific notation ourselves and just multiply everything by, what, 1 trillion. And then you can have a whole bunch of decimal places and just have everything shifted left. And then it'll be called fixed point arithmetic. We might have an assignment about fixed point, and we might not. But it's just something to know that decimal numbers have 16 digits. It's in the slide. About 16 digits. That is not actually a fixed number because computers store things in binary, not in base 10. We're used to decimal, which literally means 10. So counting up to 10, computers count up to 1 and then spill over into the next power of 10, which would be a power of 2. We'll talk a little bit about binary because it does matter a little bit. In general, we don't care. Python, we're just going to use normal human numbers in base 10. So there is a maximum and a minimum number that we can have in our programs when we use floating point. So I'm just going to copy in. These are 2 lines of code. This is our first import. And on my computer, this is the float info. So here's my maximum number, 1.79 times 10 to the 308. 8. It's a big number. So, and my minimum is approximately 2.2 times 10 to the negative 308, which is a very, very small number. And there's some other information that we actually don't really care about too much. What epsilon is, which is a very small number. And that is, you can, based on your computer, you'll find out that you might have a different maximum for your floating point. If you're running a 32-bit version of Python, you might get a 32-bit float, and then you'll have less space, less ones and zeros to store a number. I have a 64-bit installation, so I have potentially a larger area to store my floating point. That's all fancy stuff. What do I care about? Floats have fixed length and fixed precision. You can only get 16 decimal places. Past that, you have to work harder for it. It's not free. We'll talk about imports later. I already talked about them once. That's how you do it. So that's it for today. Try running a program. Try doing a little bit of math. And next class, we'll talk more about data types. We'll add integers to floats, and we'll find out what happens. Do you get an integer or a float back? And we'll talk about more Python. So I'm looking forward to seeing you there, or at least you seeing me, I suppose. Have a good day.